Hi everybody, welcome back to my channel. I'm really happy that you joined my next video, and of course I have another dyno run for you, and this time I have the Rockford Fosgate Punch 100.2. This one is rated 50 watts per channel of continuous output power into a 4-ohm load, both channels driven, and I was really impressed about the dynamic abilities of the amplifier, and now I understand why so many people said these amplifiers are also pretty nice for mids and highs. This video is also subscriber supported. I just wish to say thank you to all my subscribers, all my supporters, to everybody who ever sent me old school stuff from Rockford. Thank you very much. Enough of talking, let's go to the dyno. Let's start with 1 kHz. Both channels driven. I have connected 8 ohm mono load. I go straight to the clipping point, as usual. There's clipping. I go back, take this one. And I have a maximum voltage of 61.6, and I go with my cursor to the top of the positive waveform. And I can confirm we have 61.2 or 0.6. Let's calculate with 61.2. That's more conservative. Bridged mono 8 ohms. I have measured 240 watts of continuous output power. That means we have 120 watts of continuous output power to the clipping point into a 4-ohm load per channel, both channels driven. This is more than 50 watts. A little bit more than rated. My bad, people, I just forgot to say let's zoom to the scope and start the dyno. So here is a voltage I wanted to show you. It shows 61.6. I'm on 61.6, but I said let's go a little bit deeper and let's calculate with 61.2. Let's check the amplifier's efficiency at 4 ohms, both channels driven. The power supply has to deliver 26 amps. I have calculated an efficiency of 67%. Continuous power test, 4 ohms per channel with a 50 Hz input signal. Oh, clipping, I go back. And I have a maximum voltage of, it says 61.2. Let's go a little bit deeper. Let's calculate with 60.8 volts. And with 50 Hz we have an output power of 237 watts. That's 118.5 watts of continuous power into a 4-ohm load with a 50 Hz signal. And the dynamic power test, 4 ohms per channel, both channels driven. I take one shot and you can see I have 20 cycles in this case, free of clipping. I go to the last cycle, also free of clipping. .6 volts. Around 1.5 watts more. We have 121.5 watts of dynamic power into a 4-ohm load, both channels driven with 20 cycles. With 8 cycles and only 1 cycle I have the same output power, so I skip the 8 and 1 cycle test. And the continuous power test with 1 kHz into a 2-ohm load per channel, both channels driven. Oops, clipping. Take this one. And the scope says 52.8 volts. That's correct, 52.8 volts. That's 357 watts into a 4-ohm mono load continuous power. That's 178.5 watts into a 2-ohm load per channel, both channels driven. And let's have a look how many amps the amplifier is pulling out of the power supply. 44.7 amps. With continuous power into a 2 ohm load per channel, the amplifier has an efficiency of 58%. Continuous output power into a 2 ohm load per channel, both channels driven with a 50 Hz signal. To the clipping point. Clipping. I go back. Take this one. We have 52.8 volts. That means we have the same output power at 50 Hz like the output power with 1 kHz. Dynamic power test 20 cycles into a 2 ohm load with 1 kHz. I have all cycles at the same voltage level. So we have 56. It says 56. I will say 55.6. Mono 4 ohms, we have 396 watts. That means we have 198 watts per channel into a 2 ohm load of dynamic power with 20 cycles. And then I calculated an efficiency of 64.7%. Dynamic power test with just 8 cycles. Looks really good. All cycles at the same voltage level. I go to the last one. Check for clipping. Looks nice. So I go to the first one. Yes, its scope says 56.8 volts. volts, 55.6. Maybe one of them is a little bit higher because it shows 56.8, but let's calculate with 55.6 volts. And with 8 cycles we have the same output power like the test with 20 cycles. So I jump to the test with just 1 cycle and we will see if we get a little bit more output power out of the amplifier. So what do we have here? 56.4 volts, 57.2, a little lower. My scope doesn't catch it always correctly. Yeah, let's say 56 volts. Just a few watts more with just 1 cycle. Mono 2 ohms test, 1 ohm per channel. I know that these amplifiers can take 1 ohm loads dynamically because they have been rated with a power cube also in a 1 ohm load per channel. I take my first cycle. I will reduce the gain a little bit. It says 46.4 volts. Let's take 46 volts. On the first cycles we have an output power of 529 watts into a 2 ohm mono load of dynamic power and 264 watts into a 1 ohm load per channel, both channels driven. But let's observe the last cycle. Okay, we have a little bit clipping. I will also reduce my input signal. So we have, let's say 44.8 volts on the lowest cycle. Even in the last cycle the amplifier delivers 502 watts. That's 251 watts per channel into a 1 ohm load of dynamic power, 20 cycles. Dynamic power test with 8 cycles. I start at the last cycle first to see if it's free of clipping, and yes it is. And we have an output voltage of 47.2 says the scope. Let me go a little bit deeper. Let's say 46.8 volts. Also 46.8 volts. We have 547 watts, mono 2 ohms, both channels driven. Now I'm hunting for absolutely peak power for just 1 millisecond with 1 cycle, dynamic power 1 kHz. We have a peak voltage of 52.8 volts, 697 watts, mono 2 ohms, and 348 watts into a 1 ohm load per channel, both channels driven for just 1 millisecond. Almost 700 watts, mono 2 ohms. Some amplifiers have good peak power for a short time, some don't. This one definitely has a lot of dynamic headroom.
Thank you very much for watching. I hope to see you in my next videos. Bye bye.